Well, the BrahMos missile has had a huge impact during Op Sindur. It's quite clear, and not just on the basis of what the Pakistani Prime Minister has now said, but also on the basis of satellite imagery that it is likely to have struck major Pakistani targets, whether they were, who knows, military air bases or perhaps even terror centers. Now, the Indian Air Force isn't disclosing which weapon was used where, but there is a sense that the BrahMos most certainly was. Joining us now to talk about this very impressive weapon system, Atul Rane, former Director General and CEO and MD of BrahMos Aerospace, somebody who knows a thing or two about that missile. The BrahMos has evolved over a period of time. I would suggest, on the basis of what I know, that when it came in, it was a Russian missile, but at this juncture, given the infusion of technology, given the fact that it's changed a lot, it is as much an Indian weapon system as anything else. Would you agree?
Yes, to a certain extent. What happens is when BrahMos was conceived, we did use a baseline principle that we would work on one of the Russian engines. We started off with about 7% of the missile being indigenous, that is contributed from our side, quickly upped it to about 15%. But after that, it was a process of the Indian industries picking up production and indigenizing stuff which was manufactured in Russia. Slowly over the years, the indigenous content has risen with the various components coming in. And I must say the Indian defense industry has done a commendable job on this. Of course, with the hand-holding of the quality assurance people, the engineers from DRDO, and of course the young BrahMos people who are around. And today we are sitting at close to 84%.
That's remarkable.
But what is flying right now is only about 74-75%, because it takes some time before the indigenized subsystem or system gets qualified to get into a combat missile.
What does it feel like now, sir, to see the BrahMos having performed as well as it has in Op Sindur?
First of all, hats off to the men behind the machine. The Indian Armed Forces have learnt and used a weapon of high caliber. And that is what actually has created the huge success. BrahMos is only a tool. The tool which was created, conceived, and designed, developed, produced, inducted, and now used in a time of requirement. Not many people get to see this in their own lifetime. And a few of us, a generation before me and a generation after me, I think we are very, very lucky people and extremely satisfied that the BrahMos missile was used. Of course, probably used is what I would have to say right now.
Probably used. So we'll stick to that official jargon. Sir, one of the key challenges, and of course this project has had lots of challenges, that's what basic engineering is all about, and we've worked through those challenges, but integrating it with the Sukhoi 30 aircraft, as I understand it, when we went to Russia and said, help us integrate it, they quoted a very large price. And so we said, okay, fine, thank you very much, we'll do it ourselves. Could you tell us about how challenging that was? Because it's not just integrating a missile with an airframe, it's integrating the missile with the fire control system, with the head-up display symbology, with the radar and a lot more. So the entire package, tell us about that mission.
Yeah, you see, the cost part of it is always something which all of us crib about. Anything imported or anything import substituted starts off with a large cost. Yes, when the management of BrahMos Aerospace along with DRDO decided that the cost of trying to get it done from outside would be too much, HAL also came on board, and people worked tirelessly. I must tell you, it's not just the integration of the missile to the aircraft. As you explained, even the electrical interfaces, the software interfaces. The Indian Air Force also chipped in because they already knew a lot about the Su-30 in the Bangalore place where they work. And even bigger challenge was, we didn't know the Su-30 inside out. We had to create wind tunnel models. We had to create the separation studies. Is BrahMos safe to separate from the Su-30 and fly safely, not just for the missile, but for the aircraft, because the mother aircraft is much more precious than the BrahMos missile. It was a very long journey, and I must say there would have been at least 200 to 300 engineers, armed forces personnel, and HAL personnel working on this particular project. It was a challenge. And mind you, the heaviest weapon being carried on an aircraft is the BrahMos air version on the Su-30.
Could you tell us, sir, about what makes the BrahMos so difficult to intercept? Is it just its speed alone, or are there other factors?
We can't talk too much about those sort of things, but yes, speed plays the maximum factor. It's fast. It's hugely fast. We have been working on many improvements over the years, and the thing is, it's a very slick missile compared to what it does, and hence the radar cross section is also fairly low. High speed, low RCS. What more do you want? There are a few other things, but we won't get into that.
No, but I'll tell you what I've read about. It's all over the net that terminal maneuvering at high velocity, possibly going up to 12 Gs and S-shaped maneuvers, is that a big factor which makes it very difficult to defeat?
Well, at a high speed, maneuvering is tough. We have done it, and it's there in different ways. I won't bring out numbers and what exactly, but the BrahMos has evolved into a weapon which need not just fly like an arrow. It flies like a missile, and a missile which hits the target. As I keep saying, a missile normally, it has, everyone talks about a miss distance or a circular error of probability. In BrahMos, over the days, as we kept working on the missile, different tests which we have done, the user trials which they have been doing to learn themselves and train themselves, I have started saying that BrahMos is not a missile, it's a hitile. It hits the target it's designated to hit.
And how much of a challenge was that? Because as I understand it, again, the seeker is different now. It's an Indian seeker. All of you have thought through the technology over there. So that's Indian engineering, hardware and software, obviously, which has gone into making this missile as accurate as you say it is. Could you tell us how, that was a huge learning curve for us in the country?
You see, learning is a process. It starts from a baseline and we keep improving it. Over the years, IGMDP has taught, DRDO has worked a huge amount on missiles. BrahMos has got a lot of stuff from the IGMDP in. I'm one of the IGMDP guys also at one time. And most of us
the Integrated Guided Missile Program.
Integrated Guided Missile Development Program. Now, the seeker has been a bugbear for all of us for years together. But the challenge was that it needs to be done. We started 20 years ago. And today it's capable of flying. And it's not just the seeker alone, because what happens is the integration, the accuracies of the hardware, the airframe, then coming down to the navigation system, the tweaks we have to do to the navigation system, the control, onboard control, all this put together creates the accuracy of missile. And people have been working tirelessly in DRDO, in BrahMos Aerospace, along with our joint venture partners, of course. And it's turned out to be a fantastic weapon.
And you've got different avatars. We've been talking about the air-launched version, but you've also got a surface-to-surface variant. How is that a significant evolution of the missile, considering that it could be used anywhere, in the deserts, in the mountains? It could be used to hit targets behind mountains. So in terms of how you guide the missile, its trajectory, basically how smart the missile is, how has that also been a process?
See, when it was conceived by my bosses, I was a young boy in those days, it was decided to be only an anti-ship cruise missile, supersonic cruise missile. But then once it started working, it started coming out that one shouldn't be just sitting with one fantastic product. One needs to make sure it's delivered on time, which is a mantra of BrahMos actually to deliver things on time. And the third pillar of all this is let us keep improving. So we moved quickly from an anti-ship cruise missile to a land attack missile. And once the Indian Army got in with it, and they said that we would like to see some more stuff that is launching from high altitudes, having waypoints, getting over mountains. So all this was done in steps. There are no clear-cut, block 1, block 2, block 3, which normally people talk about. We did try to talk about it, but it's been a sort of a seamless improvement over the years. And today, it's literally a universal missile. The missiles which are launched from the surface, that is either from the Indian naval ships or from the mobile autonomous launchers which are there with the Indian Army, these two missiles can be swapped without any problem. So the whole idea was to create a universal missile. The dream is to have a cartridge, a canister filled, a missile filled in a canister, and you pick up that canister and put it wherever you want, and the missile can be used. Of course, a little tweak of software and things like that. The air version is a little different because the Su-30 can't carry that heavy a missile. And so there were a little bit of changes done for the air version as such. But it's been a fantastic journey. And it's not, you can't give the credit alone to the people who have designed, developed, and produced. And as I say, using such a sophisticated piece of machinery requires knowledge and courage to use it. Thank you. It was used in Operation Sindur. If it has been used, we are very, very, very happy.
I'm pretty sure it has been. Let's talk about basic metallurgy. The Godrej Group has done a great job in the fabrication of the missile itself. Without that, there is no missile. That requires micrometer-specific clearances and an immaculate form with no chance of error. I mean, it's a multi-million-dollar missile. How was it easy, difficult, challenging to get the basic metallurgy done to that world-class standard?
I must say it's not only Godrej who have worked on the metallurgy of the missile, because they were the first. You see, there were these 2-3 industries who came out upfront saying, we will put in our effort, we will put in our input, we will put in our money. But we want to be part of this path-breaking, futuristic missile. In those days, it was futuristic. Today, it's current. Godrej put in a lot of effort. It took us approximately about 7 to 8 years before the first airframe could be flight tested in a development trial. So that shows what sort of level we had to go to. It's not just the machining, it's the welding, the blind matings, and various materials being put together. It's a huge effort, and they put in the manpower, they put in the expertise, the people on the shop floors. Hats off to them. I visited Godrej a few times, and I must tell you, world class. They are capable of doing any miracle which a designer wants. Many times we say we should design for production so it can be produced. But here was a design which many people thought cannot be produced. And Godrej came up with the metallurgy, L&T with the composite materials and the composite airframes. Unbelievable. I mean, it's been a journey where people have slogged, worked, fought. And now today we are all a big, huge, happy BrahMos family.
So you refer to the BrahMos now as contemporary or current technology. What is the future of BrahMos? Are we going to go hypersonic with the BrahMos? Does it really have potential for evolution, or is it just increased ranges that you can work with?
We started as a 290 kilometer missile. We're a little more than that right now.
Yeah, just a little, so right, just, sir? That's understating.
and we're a little faster also. So things can be improved, things can work out. But, any sort of incremental research takes time. And also, of course, money. And it's being put in. The efforts are being put in. The current BrahMos in its current size and shape has a limitation. But it's a limitation which is unbelievable. It can go somewhere where no one else has gone to, almost. I mean, I'll put it that way. But it will take another little bit of time. The ball has been set rolling, so we should see it very soon. But what is the other version of BrahMos which one could look at? Make it smaller, as potent and smaller in size, so that one can put two of the BrahMoses on one aircraft instead of just a Su-30 carrying one BrahMos. Why not all the other aircraft being done? So the design has already started. We have already reached almost reached the point of cutting metal, and we're looking at the BrahMos next generation, which is a smaller missile, equally fast, of course lighter. So the kinetic energy when it hits would be a little different, but still good enough to destroy targets. And the Tejas Mark II will carry the BrahMos NG, one each under the wings. So two BrahMoses on each Tejas, and possibly a full-scale large BrahMos under the belly of the Su-30 and two NGs under the wings of the Su-30. We are looking at a huge potential, and that also opens up many other customers who might want to come in.
All right. Mr. Rane, thank you very much for speaking to us. It is a moment of great pride for all of us who've tracked this for so many years. This is a missile that has truly, truly come of age. Thank you very much for being with us.
Thank you for digging me out from wherever I am. And I must say, it's not just me, it's a lot of people who have worked on it. And it's hats off to all of them. Congrats to everyone. And it's a job well done.
Thank you,
Thank you very much for having me.
Thank you, sir.